Children, please be ready for the pledge. Place your right hand on your heart and repeat. I, Shruti Narayan, commit to be vigilant and bear in mind at all times the risk to myself and my colleagues from COVID-19. I promise to take all necessary precautions that prevent the spread of this deadly virus. I promise to follow and encourage others to follow the key COVID appropriate behaviors. To always wear a mask or face cover, especially when in public places. To maintain a minimum distance of 6 feet from others. To wash my hands frequently and thoroughly with soap and water. Together, we will win this fight against COVID-19. Today, we will start with a new lesson, atmospheric pressure and winds. Air, which has weight, is made up of a number of gases. It therefore exerts a pressure called atmospheric pressure, which varies from time to time and from place to place. Atmospheric pressure refers to the force per unit area exerted against a surface by the weight of the air above that surface. So the unit for expressing pressure is millibars, and it is measured with the help of a mercury barometer. The average atmospheric pressure at sea level is 1013.25 millibars or 760 mm. 760 mm actually refers to the height of the column of mercury in a barometer at sea level. As the height increases, the atmospheric pressure also decreases. The standard instrument used for measuring atmospheric pressure is the mercury barometer, invented by the scientist Galileo and his assistant Torricelli in 1643. So, the ordinary mercury barometer consists of a long glass tube about 1 meter long, sealed at the upper end, as you can see in this picture, and open at the lower end. The lower end is inverted in a bowl of mercury whose surface is exposed to the air. This gives the pressure of the air and can be read quickly from the scale on the glass tube. Any liquid could be used for this purpose, but because it is the heaviest known liquid, mercury has been chosen. Another instrument which is used for measuring the atmospheric pressure is the Fortin's barometer. It is very accurate. It consists of a glass tube around 85 centimeters long containing mercury dipped in a container of mercury. The flexible bottom of the cistern is adjusted with the help of a screw to fix the zero level above which the height of the column may be measured. The tube is encased in brass for protection. The mercury level can be seen through the glass slit. The scale is inscribed on the sides of the slit, as you can see, and is marked in centimeters of mercury or millibars. It gives accurate readings, but it is not easy to transport, and this is one of its disadvantages. The next instrument for measuring atmospheric pressure is aneroid barometer. The word aneroid means without liquid. It is portable and convenient for outdoor measurement. Now, a very important term which is related to atmospheric pressure is the pressure gradient. Pressure gradient is defined as the decrease in pressure per unit distance in the direction in which the pressure decreases most rapidly. Or, in other words, the rate of change of atmospheric pressure between 2 points on the Earth's surface is called the pressure gradient. Winds always blow from areas of high pressure to areas of low pressure. Now, what is a wind? Wind is actually the horizontal movement of air, and winds always blow from areas of high pressure to areas of low pressure. And This is how the winds transport heat and moisture from one region to another and thus help in the occurrence of precipitation and affect both temperature and humidity. Now, to explain the pressure gradient again to you in simpler terms, the difference in pressure between 2 points is called the pressure gradient in very simple terms. Alright, so on the weather chart, this pressure gradient is indicated by the spacing of isobars. Now children, isobars, these are imaginary lines joining places which have the same atmospheric pressure. So what happens is wherever the isobars, now on the right hand side you can see the isobars are drawn. They are joining places which have the same atmospheric pressure. Now on the right hand side, as I told you, you can see the isobars. Now when the isobars are closely spaced, it indicates that the pressure gradient is steep. So obviously over there the speed of the wind is more. There are fast winds. And wherever the isobars are widely spaced, which you can see in brown color, it has been shaded. Over there, the pressure gradient is gentler in nature, so the speed of the wind is also slow. Like if you see on the left hand side, I have shown that the steep slope, if you imagine a rock rolling down the steep slope, the speed will be more. On the other hand, where the slope is gradual, over there if you roll down a rock, the rock will roll down slowly. So in the same way, when the pressure gradient is steep, meaning when the isobars are close to each other, the speed of the wind is more. And wherever the isobars are widely spaced, the pressure gradient is gentle, and so the speed of the wind is slow. Now let us study about the factors affecting atmospheric pressure. The atmospheric pressure varies from time to time and from place to place. So the atmospheric pressure actually depends on the following four factors. Altitude means the height of a place, temperature, water vapor, and rotation of the earth. So the first factor is altitude, meaning the height of a place above the sea level. Higher the altitude, lower the pressure. So with the increase in altitude, there is a decrease in atmospheric pressure. For every 110 meters of ascent means for every 110 meters increase in height, there is a decrease of 1 centimeter of mercury. The atmospheric pressure is highest at the sea level. Now in this slide, you'll understand why the pressure decreases with altitude. At higher altitude, the air is thinner or less dense than the air at sea level. The maximum air density is at the Earth's surface, meaning close to the near the sea level, and air density decreases with height. The fewer number of gas molecules at higher altitude means fewer molecular collisions and a decrease in air pressure. Since the atmosphere is highly compressible, the overlying layers exert pressure on the low-lying layers. So in this picture, you can clearly understand why the pressure decreases with the increase in height. Now, as the pressure decreases, obviously the amount of oxygen available to breathe also decreases. At high altitude, the atmospheric pressure and available oxygen gets so low that people feel breathless. Mountain climbers use bottled oxygen when they ascend very high peaks. And they also take time to get used to the altitude because quickly moving from higher pressure to lower pressure can cause decompression sickness. So decompression sickness is also called the bends, is a problem for scuba divers who come to the surface too quickly. So aircrafts also, in the aeroplanes, they create artificial pressure in the cabin so that the passengers remain comfortable while flying. That is why children, people who have hypertension, meaning who have high blood pressure problems, people with heart problems, generally they are advised not to go to very high altitude areas because it is risky for them. Now let us understand the factors which affect the atmospheric pressure again. Altitude I have already explained. As the height increases, the pressure decreases. Now let us study about the next factor, that is the temperature. There is a close relation between pressure and temperature of air. When the temperature of air rises, it is heated up and it expands. Thus, it occupies more space and becomes lighter. Lighter air exerts less pressure. On the other hand, when the temperature of the air falls, the air contracts and occupies less space. Thus, the cold air is heavier and it exerts more pressure. So, the general rule is that higher the temperature, lower the pressure. Conversely, lower the temperature, higher the pressure. In other words, there is an inverse relationship between temperature and pressure. A rising thermometer shows a falling barometer, meaning when the temperature rises, the level of mercury will come down. And a falling thermometer shows a rising barometer, meaning when the temperature falls, there is an increase in pressure and obviously the mercury level increases. The third factor is water vapor. So children, water vapor is lighter than the air of the atmosphere. It has been found that the density of water vapor is about 40% less than the density of important gases such as nitrogen and oxygen, which are found in the lower layers of the atmosphere. Thus, contrary to the general belief, dry air is heavier than moist air. One of the major causes of low pressure in the equatorial regions besides high temperature is the presence of high amount of water vapor. Now another thing by which you can understand why water vapor exerts less pressure is when you heat water. Okay, you must have seen that the water vapor rises. Why does it rise? Because it is lighter than the surrounding air. Therefore, air which holds a lot of water vapor exerts less pressure. The last factor is the rotation of the earth. Due to the rotation of the earth, bulk of the air at the poles is thrown away towards the equator. Now, since the equatorial region receives great amount of heat throughout the year, the air becomes warm and light and therefore it rises and creates low pressure. Another reason why there is low pressure at the equator is that the rotation of the earth generates a centrifugal force which tends to throw the air outwards. So that is why, because the speed of Earth's rotation is maximum at the equator, the centrifugal force is also maximum, which results in minimum pressure over there. At the poles, the cold, heavy air sinks down and it creates high pressure. In fact, temperature and rotation of the earth together contribute to the formation of the world pressure belts, about which we'll study in the next chapter. So children, atmospheric pressure or air pressure is an important parameter in predicting weather. In general, weather becomes stormy when the air pressure falls, generally due to warm, humid air or convergence of air masses at the surface of the earth, which cause convection and rising air, and becomes fair when the air pressure rises. So when the pressure is high, it is indicative of fair weather because of dry, cold air or divergence of air masses. When a low pressure system moves into an area, it usually leads to cloudiness, wind, and precipitation. High pressure systems usually lead to fair and calm weather.